Okay, we're gonna move into lesson 9.3 on writing exponential functions today. I know you guys have had some difficulty with the graphing part of this, working through the Alex site. I'm going to take all into account, so don't get too caught up in those kind of questions where the graph's really not cooperating with you. Today is going to be more algebra based, less graphing. So this is going to be a process, an algorithm that you're going to need to know, and you'll have these notes to use to help you guide your way through it. But today we're going to work on writing an exponential function to represented by a situation. So the first thing we're going to do is look at how we are given 2 points. If we're given 2 points that are on a exponential growth or exponential decay curve, how do we write an equation for the exponential function that uses these 2 points? And this is going to be, like I said, a step-by-step process. It uses concepts that we've had before, so there's not a lot of new, but there is blending of these ideas. All right, so the first thing what we're going to do to solve this is we're going to take these two ordered pairs and we're going to plug them into our general exponential function, which is y equals a times b to the x. We're going to plug the x, y's in here and we're going to create two different equations. So it's really straightforward stuff. Here, we're going to take the ordered pair 1, 6. We're going to take y equals a times b to the x. I'm going to replace the y with 6. I'm going to replace the x with 1. Okay, now we all know b to the first is b, right? So we'll simplify that as we work with it. Now we're going to take our second order pair, 324. We're going to do the same thing. Y equals a times b to the x. I'm going to replace y with 24 and x with 3. So here's my second equation. All right, so what we now have is, if you think about it, we have two equations with two unknowns in it. So we're going to solve this system of equations by substitution. Okay, so here's equation 1, 6 equals a times b to the first. Here's equation 2, 24 equals a times b to the third. All right, we're going to use substitution. We've worked on this before. So I'm going to take equation 1 and solve for a. So here's equation 1, 6 equals a times b. Remember, b to the first is just b. This is multiplication. 6 equals a times b. Solve for a. I'm going to divide each side by b. That will cancel. A is equal to 6 over b. So I know the value of a is a equals 6 over b. Okay, now in substitution, we take the answer we just got and substitute it into the other equation. So equation 2 is 24 equals a times b to the third. I'm going to replace this a with 6 over b. So this a is now 6 over b. So what that's done, and we've done this in the past, is now we've replaced this variable with an expression that has b in it. So now the only thing in my equation, the only variable in this equation now are b's, so I can work to solve for b. Now remember here, this is really like b cubed over 1. So I get a b in the denominator, a b cubed in the numerator. So if I cross cancel here, I'm going to be left with b squared. So I got 24 equals 6 times b squared. That's just simplifying, exponentials. Divide each side by 6. So now I got 4 equals b squared. Take the square root of both sides to eliminate the square. Remember, square root cancels a square, and b equals 2. So I now know specifically the value of b. b is now equal to 2. So take b equals 2, and now we're going to go find a. I'm going to take either equation. This one's a little simpler. So I'm going to take equation 1, 6 equals a times b to the first, and I'm going to plug 2 in place of b. So 6 equals a times 2 to the first. 2 to the first is 2 times a is 2a. So 6 equals 2a. Divide each side by 2. A is 3. So this process we've done before. I now know a is 3, b is 2. Remember, the objective was to write an exponential function that would go through these points. So I'm going to take my information. I now know a is 3 and b is 2. I'm going to take the general exponential equation, which is this. I'm going to replace it, a with 3, b with 2. There's your answer. So y equals 3 times 2 to the x. This exponential function will go through the points 1, 6, and 324. And you know it's exponential growth because the base here is 2, which is a number that's bigger than 1. So the curve is going to go like this. That makes sense because 1, 6, 324, you can see you're growing, getting bigger as you go to the right. Okay, so that's the process. All right, we're going to do it again. New set of numbers. Okay, so here are my ordered pairs, negative 120 and 1, 5. Okay, so the first step is to create two equations using my two ordered pairs in this format. So I'm going to take negative 120 and I'm going to take my y equals a times b to the x, which is the general equation for an exponential function. Replace y with 20, b with negative 1, and there's my first equation. Second equation, take the ordered pair 1, 5. Okay, start with your general equation, y equals a times b to the x, replace y with 5, b with 1, and we have 5 equals a times b to the first. Okay, so we have two equations and two unknown variables. So we're going to solve that system. So here's my system. Equation 1 is 20 equals a times b to the negative first. And equation 2 is 5 equals a times b to the positive first. Okay, so it's the same three steps here. Step 1, solve one of the equations for one of its variables. Well, equation 2 would be easier to solve for a since this is b to the first. So really this is 5 times a, 5 equals a times b. I'm solving for a, so I'm going to divide both sides by b. So a equals 5 over b. So I now know the value of a, or an expression that represents the value of a. I got to plug it into the other equation. So the other equation, equation 1, was 20 equals a times b to the negative first. I'm going to replace the a. I'm going to substitute in place of the a 5 over b. Now this is where we've learned this, okay, but we have to recall b to the negative first could be rewritten as 1 over b. Remember, if the exponent's negative, to make it positive, you move it into its opposite position. Well, this is really over 1 right now. So if I move it to the denominator, it will become positive. Okay, so b to the negative first is 1 over b. Now multiply tops and bottoms here, and I got 20 equals 5 over b squared. Now we want to solve for b squared, so I'm going to multiply both sides by b squared. If I multiply b squared on this side and b squared on this side, the b squareds will cancel, and I'll have this line, 20b squared equals 5. Okay? Divide each side by 20, because we're working to isolate b squared here. Divide each side by 20, and I got b squared equals 5 over 20. We want to get this b to become just a b, not a b squared. So to undo the square, we take the square root of it. Okay, square root cancels the square. 25ths, I made 1/4. That's just reducing the fraction. The square root of 1/4 is a half. Okay, so now I know b is 0.5, which is a half. Now I got to find a. So I'm going to take my second equation, 5 equals a times b to the first. I'm going to replace b with 0.5, substitution. And 0.5 to the first power is 0.5. So this is 0.5 times a. I'm going to divide each side by 0.5, and a equals 10. So a equals 10, b equals 0.5. Those are the two values that we found. There's the equation we want to create. So I'm going to replace a with 10, b with 0.5, and here's my answer. Now this represents exponential decay because this number is between 0 and 1. All right, so if you were to graph it, it would kind of be coming down like this, swirling this way. All right, that's that process. Okay, the last thing we're going to do is write an exponential function given a graph. All right, so here's the graph. You can see this is exponential decay because it's coming down, crossing, and it's going to get really close to zero, but never get there. Okay, the way we do this is really what we did in the first two slides. We got to determine points that are on this graph, and then we're going to use those points to write an equation, but we do have a little secret weapon here. First of all, this is the part that I think they take a great assumption that you're going to get this. We know -2 is at 10. We can see that, right? -2, 10. And it looks like -1 is right between 6 and 4. So it's -1, 5. Okay. At 0, this is actually going to be 2.5. Now, for you to be able to do that without help is kind of tough. So this is where I'm a little critical of what the book's doing here. And then at 1, it says 1.25. I mean, again, that's tough there's no way you can just do that by looking at it. But nonetheless, I think tonight you're going to get this information. You won't have to try to pick it out of this graph. But now I have 4 different ordered pairs, and we can choose any 2 of these ordered pairs to help us write the equation. But what we're going to do is we're going to pick it so that we cut our work down. All right, so I'm going to choose 2 points. And what I want to do is I'm going to choose this point for sure, 0, 2.5, because this one is going to allow me to get an answer real quick, and I'll show you what it looks like. So if I go 0, 2.5, and I've substituted into our y equals a times b to the x, y is 2.5, b is 0. Okay, anything to the 0 power is 1. So b to the 0 is 1. That means I already got my a. A is 2.5. So now I cut my work down. Now I'm going to take another point. I use 1.25, and I'm going to write its equation. Y equals a times b to the x. So y is 1.25, x is 1. Okay. That's really 1.25 equals ab. Now I already have a. So I just got to find b. So all I'm going to do now is substitute my a into the other equation. I just saved myself some work. So 1.25 equals a times b. I'm going to replace a with 2.5. And I get b to be 0.5. My a is 2.5. My b is 0.5. Again, we're trying to write an exponential function. Here's the exponential function in general. I now know a is 2.5. I know b is 0.5. And there it is. Okay, now look back up here. Does that make sense? Yeah, that's exponential decay because this is a number between 0 and 1. So we're going to be going down. Okay, so that matches that graph. So tonight what you got is all your questions are based on graphs. And really the graphs, if you get a chance to get a 0, for an x, it makes your life a lot easier. If you don't get a 0, then you use the process that we did in the previous 2 slides. Okay, so this is it's not 9.1, it's 9.3. I thought I had that corrected. All right, so this is lesson 9.3. There's more information that you could use. Oh, there it is. There's more information you can use on the site, so you can go to the site and get more help with you need it. Your homework is on Alex. Okay, so I'll let you guys get